Hey guys, welcome back. This is part 3 on how to make a third-person character controller. In this lesson, we're going to be going over how to make the camera mechanics and have it orbit around the player with the mouse's input system. Alright, let's jump straight into the code. So starting out inside the third-person camera class, I've already gone ahead and replaced my start method with the initialize method, which takes one parameter, being the transform, which I've called follow target. So go ahead and create this method now if you haven't already. Then you'll also want to create a private transform variable at the top, which I've just called follow target. Within our initialize method, I'm going to set this follow target to be equal to the follow target that we pass in. Then I'll create a new serializable float at the top of my class called follow distance, and I'm going to give that a default value of 7. Next, I'll create a new public method called onLook, which will take in a vector2 as its parameter. Then I'll create another private variable of type vector2, and I'll call that one look as well. Now within my onLook method, I'm going to set this look to be equivalent to look that we pass in through the method. Back inside of our character controller class, just underneath this onRun method, I'm going to create a new onLook method. And that's just tied to the player inputs class that we have attached to our character controller in our Unity editor. So that's going to take in a value of input value, and I'll just call that value. Now again, at the top of my class, I'm just going to create another private variable. This one's going to be of type third-person camera, and I'll just call that one TPC for short. We'll want to set that one up inside of our awake method. And I'm essentially going to be instantiating the camera inside of this awake method. So let's just call the instantiate method, and then we'll want to grab a game object for the camera that we're going to be creating. So I'm going to create a new serializable game object, and I'll call that one camera prefab, and that's the value that we're going to pass into our instantiate method. So I'll just pass in default values of vector3 0 and a quaternion identity for that one, and then at the end of the method, I'm going to call get component, and we're going to want to get the third person camera component. Now just underneath this instantiate method, I'm going to call a third person camera controller initialize method that we created, and I'm going to pass in our follow target transform. So with that set up, if we go down to our onLook method, we can essentially call our third person camera onLook method, passing in the value from this onLook method. Now we'll need to make sure that we get a vector2 value type from this one. Back within our third person camera class, I'm going to replace our update method with a late update method. Then I'll create a new vector3 within this method called local follow position. We'll want to set that one to the follow target's position plus a new vector3. I'll need to create a new serializable float, which we'll call the vertical offset. And we're going to want to pass that one into our new vector3 within our late update method. So I'm going to create another local vector3 called target position. And essentially what this value is going to do is grab the target position and calculate the offset that the camera needs to be from that target position in order to get a good view of the player. So we'll want to set the local follow position minus the follow target's forward normalized vector multiplied by the follow distance to get that calculation. Then using this target positions calculation, what we'll want to do is lerp the camera's transform position towards the target position. So let's go ahead and do that by calling our transform position and setting it to the vector3 lerp, passing in the transform position as the first argument and the target position as the second argument. Now we'll also need to pass in a timescale for that one, so I'm going to pass in time.delta time and multiply that one out by a lerp speed, which we need to create. So at the top of our class, let's create another serializable float, and let's call that one follow target lerp speed, and I'm going to give that a default value of 30, and then we'll just plug that one back into our vector3 lerp method. I'll just quickly label this code here, so if we come back to it in the future, we know exactly what it does, and then I'll also add a new label for the rotation of the camera. So for the rotation, I'm just going to call transform.rotation equals quaternion.lerp, and we'll want to pass in the current rotation, and we'll then, as the second argument, put in the follow target's rotation. Because the follow target's always facing in the same direction as the camera, or the direction the camera wants to be. So if we lerp towards that rotation, it should work out. So I've also quickly created the rotational lerp speed and set that to a default value of 30. And I'm going to plug that one in as the third argument within this lerp method, multiplying it by time.delta time. So now back in our Unity scene, if we select our follow target and we move it around, we can see that the camera is following that target as intended. So the next thing we need to do is make sure that this follow target maps to the player's position as he moves around the scene. So back within our character controller class, I'm going to quickly create a call to a method, which we have yet to create within our fixed update method. I'll call this rotate camera unlocked. So let's go ahead and create this method now. We're essentially going to be having two camera states. One where it's unlocked. If the player isn't moving, we'll be able to look around the player and see the front of the player. And the locked state will be if the player is moving, the camera is going to be fixed looking at the back of the player. This way, when we're moving forward as the player, we can rotate the camera to change the direction that the player is moving. So within this rotate camera unlocked method, I'm going to call a method which we have yet to create within our third person camera. I'll call this rotate camera follow transform. Then we'll also want to lerp our follow target's position towards the player's current position. We'll do this by calling the vector3 lerp method, passing in the follow target's position as the first argument and the transform position as the second argument. Again, I'll go to the top of my class, create a serializable field, and this will be a float for the follow target's lerp speed. Now we'll want to go back to our vector3 lerp method, passing in the follow target's positional lerp speed and multiplying that one out by time.delta time. With this set up, all we need to do is fix the rotate camera follow target method, and then it should work for us. So I'm going to go back to our third person camera script and create a public method for this one. To calculate the follow target's rotation based on the mouse inputs, we're going to have to grab the X and Y axes from the look variable that we set up prior. So I'm going to multiply our follow target's rotation by a quaternion angle axis around the look.x axis. I'm going to have to create a new float variable for the rotational input speed. I'll give that a default value of 1, and then as the last parameter within our angle axes method, I'm going to pass in vector3 up. Then I'll duplicate that line out, replacing the look axes with look.y, and then also vector3 right. The next thing I need to do is make sure that the camera's rotational input is clamped between a certain range. So I'm going to grab the quaternion angles of the follow target within a Euler format. And the first thing I'll do is set the Z of that angles to be equal to 0. Then I'm also going to create another local variable for the angle around the vertical axes. So for that one, it'll be the follow target's local rotational Euler of the X coordinate. So before we actually do the calculation for our clamps, I'm just going to make it optional. So I'll set up another serializable variable here, which will be a bool, and I'll call that one clamp vertical rotation. And I'll probably set that one to have a default value of true. So back inside of our rotational method below, I'm going to create an if statement that just asks if our clamp vertical angle is set to true. And then for the next step, we're going to have to create two more floats that are serializable, one for the minimum angle and one for the maximum angle. I'll give these default values of 300 and 40 respectively. So then again, below within our rotational method, I'm going to ask if our angle is greater than 180 and our angle is less than our minimum rotational angle, then we'll want to execute this specific code where we're going to set our angle's X value to be equivalent to the minimum vertical angle. Next, I'll add an else if check here where we're going to ask if the angle is less than 180 and the angle is greater than the maximum vertical angle. Then our angle's X will be equivalent to the maximum vertical angle. Now, just to make sure that we actually apply this clamped value, I'm going to set our follow target's local Euler angle to be equivalent to the angles variable that we created prior. Back inside of Unity in play mode, you'll see that when we move our mouse's position, it sort of orbits around our character controller's position. So that seems to be working as intended. Now, the final thing we need to do is implement some functionality so that if the player is moving the camera's sort of locked behind the player's movement system so that he's always going away from the camera's position in world space. That's just pretty generic implementation around a third-person character controller. So back inside of our code, there's one thing I'll add, which is just a range method here on our minimum and maximum vertical angles. So I'm going to set that one to 180 and 360 for the minimum, and then 0 to 180 for the maximum. So now back within our character controller class, I'm just going to create a new method, and we'll want to call that one rotate camera locked. So this will handle the functionality for when the player is moving. We'll want to fix the camera's orientation to be behind the player's position. So the first thing we'll do here is add the rotate camera unlocked method call into our rotate camera locked method. And then I'm also going to set our transform rotation to be equal to a quaternion lerp method. Now the first parameter I'm going to be adding here is a new quaternion Euler angle, where we're going to be grabbing our transform rotation's y-axis and placing it in there. The second parameter will be our look at transforms rotation and grabbing the y-axis off that one as well, and that's what we're going to be lerping our rotation towards. Next, I'll go ahead and create another serializable float at the top of my class, and I'm going to call that one rotational lerp speed. We'll plug that one back into our method and multiply it out by time.delta time. Now the last thing for us to do is call this rotate camera locked method. So I'm going to do that in our fixed update method. And we're going to want to handle the rotate camera unlocked differently. So I'm going to create an if statement here where we're going to ask if the movement vector is equivalent to vector2 0. If it is, we're going to rotate the camera unlocked and return out of the fixed update loop. If it isn't, then we'll be hitting the rotate camera locked method. And with that done, everything should work. Now back in our Unity scene, when we hit play, everything seems to be working as intended. There's a few values we need to play around with to get the camera sort of smooth and reacting to our inputs how we like. But everything seems to be correct. You can sort of orbit around the player. Then when you start walking, the player forces the camera to be behind it. So we've got pretty much a basic third-person camera controller setup working now. Thanks for following along with this 3-part mini-series. I hope you're happy with the final result. I know this lesson was a little bit more complicated than the others, so if you have any questions, feel free to comment down below, and hopefully you'll have answers. I've also got the community Discord. A link for that will be in the description down below, so I can also answer your questions there. And also, if you just want to hang out and play some games, that's the perfect place to come, so feel free to join that one. Yeah, thanks for watching, and have a great day.